Let's have a look at question 36 in this video. So we have an investor that's considering two types of investment. Now to make the decision, she randomly selects 7 monthly returns on investment 1, so got 7 there, and 10 monthly returns on investment 2. She finds that the sample variances of investments 1 and 2 are 225 and 118 respectively. Now we assume that the returns on investments are independent, are normally distributed. At the 5% level, we want to see whether the population variances of the investments differ or not. So as always, we have data on the samples. I wrote them here that we have a larger variance in the first group, which is 225, and we have 7 observations there. And we have a smaller variance of the second investment of 118, and we have 10 observations there. Now, the sample variances are estimates of the population variances. So what we are testing is actually the population variances. Under the null hypothesis, we have the assumption that they are equal, but under the alternative hypothesis, we assume that they differ, and we want to see whether that's true or false. Now, to test the difference in variances, we perform our F-test, where we take the ratio between the larger variance and the smaller variance. So our larger variance here is 225, our smaller variance is 118, and we have a ratio equal to 1.91. And as always, we're going to compare our F statistic with the F critical value. So our F value relative to the F critical value. The F critical value at 5% significance level. So we're testing at the 5% significance level, but because it's a two-sided test on variances, for the two-sided test on variances, we're going to divide the critical value into 2. Let me put it like that to see the values. So we'll have 5% divided by 2, and then we have the degrees of freedom, which is the number of observations of the larger sample variance minus 1, and the number of observations of the smaller sample variance minus 1, and that's going to be equal to the F critical value is 2.5%, and here we have the number of observations in the sample with the larger variance, that's equal to 7, so we'll have 7 minus 1, and the other one is going to be 10 minus 1. So here we have 7 minus 1 and 10 minus 1 for the smaller sample, for the sample with a smaller variance. Now, the F critical value that we're looking for with the 2.5%, and here we have 6 and 9 in the table. By the way, the 2.5% belongs to the p-value. So the critical value that we're looking for is equal to 4.32, and if it's not exactly that, don't worry, it's an estimate, because in different tables we have them slightly different, but the difference is not that big. So we got that. We have our F value of 1.91. Let's plot these two values on the distribution and see whether we reject or not the hypothesis. We have the distribution of the F distribution over here. We draw it like that. We have our rejection region from the value of 4.32. That's going to be our critical value. Anything to the right is going to be in the rejection region. Our value that we just found is equal to 1.91. So 1.91 would be somewhere over here, and we clearly can see that it's not in the rejection region. So what we give as a conclusion is that we do not reject the null hypothesis. We do not reject the null hypothesis, meaning that the variances of the investments don't differ significantly. The variances don't differ significantly at the 5% level. Now, if you have a look at the answer key, what we say is that at the 5% level, we cannot infer that the population variances differ, and the answer is true. The answer is true indeed. We do not reject the null hypothesis, so we cannot infer that the population variances differ. And that's it. We are done.